I'm not doing a video about anybody's request. This is something I wanted to do. Paper shredding, data compression, algorithms, etc. The real impact of the attack on us was not to destroy the assembled pieces or our ability to do so, but to destroy the user base of the platform that was a crowdsourcing project, to disrupt the recruitment dynamics for it, and to prevent them from winning a challenge they crowdsourced out. This was a specific challenge, but the point is that literally 2 people disrupted a group of thousands who were on literally a puzzle project where they put together a bunch of puzzles, a really hard puzzle, a bunch of sheets of paper that had been shredded and then photocopied the pieces at random, and they were supposed to take the individual fragments and put them together, and it was supposed to be crowdsourced. That's it. And they started off with just a document and putting it together. And the idea was to try, it was a handwritten document, shredded, and the idea, and this was a DARPA project, this group decided to crowdsource it, and they did an incentive program. This is exactly how you harness a botnet on computers, or in this case, you could also use this for political campaigning or anything else like that. And it demonstrated something very important. A couple of bad actors in a group can disrupt thousands if they look for a simple weakness, and even if they don't. The part about that was a problem was that 2 people involved, one of them was involved as being one of the competitors trying to solve the same puzzles, and decided, he was just doing it for fun, he decided, screw it, for the hell of it, I'm going to go through and disrupt them. How? By making it to where they don't feel they can succeed in anything. Now, what he did is he found out that you could, in this puzzle piece, some idiot, retrospect, we know he's an idiot, allowed you to grab more than one piece at once and then move them. Nobody could stop you from doing it. That was not excluded. One flaw. But the other flaw is, and again I'm going to re-emphasize this, a pair of individuals disrupted several thousand people who had a financial incentive and were interested in problem solving and puzzle solving as an experiment. This is literally like you and me and a bunch of other people working on some large problem we're trying to solve on the internet, and a couple of people come in and figure out what weaknesses we as humans have and manipulate and exploit it. All the motivation generated by weeks of good public relations, a fun task, a smart financial incentive scheme, all evaporate in the face of attacks by a single person and his friend at one point, lasting no more than a couple of hours. This was a long-term project. They were trying to win prize money from DARPA to be able to prove it was possible by testing it. This is the best way to do it. Can you reassemble a shredded document in a short period of time? And this was shredded on level 2, as most of us would call it. It's the wrong level. It actually has different levels. Okay? I'm going to repeat this. A couple of trolls tore down a system that had worked in a previous attempt on a previous project flawlessly because they found a flaw, and it's not the flaw. 2 people can do more damage than a bunch of people can succeed at if they know how to manipulate the situation. Don't you ever forget that. One person can make a difference, either by doing something terrible, you can think of 100 examples over the last few decades, or just because they feel like maliciously messing with people who are succeeding because he was their competitor. It's easier to break things than it is to fix things. It doesn't take a brilliant person to break a lock or pick it. Well, but a locksmith better know how to break a lock or pick it. He better damn well know how to do that. A4 paper, size, 210 millimeters by 297 millimeters approximately. That's 62,000 square millimeters. Now, 62 something. If you're a computer geek, even though this is not a square, you immediately think, let's just call it 64,000 millimeters. That's wrong, but I can do the math easy. That's 2 to the 16th power. That's this twice. Emphasis added. Or 8 0.27 inches by 11.69 inches. Because meh. So the pieces per shredded document versus the surface area of each piece if you shred it. Is it surface area, shape, or minimum size? Some of these things involve cutting these things into strips that are 0.5 millimeter across or something crazy like that to make it to where individual letters of the alphabet are not resolvable, or probably not. Most of you can look at a drawing of the letter R or M and figure out what the letter is. So let's talk about this. The first method is shredding it in strips. That's why it's called shredding, actually. There are other methods that tear them in random shapes, but that makes it easier to put them together because they have unique edges. Everybody's seen that puzzle that has all the pieces looking almost identical? Yeah. So squares are probably better. Actual real squares would be very good. 39 strips, not 40. That works out to 761, not 762 millimeters, or 0.3 inches wide, 1/3 of an inch wide. That's pretty big. And if you use fine pitch, a very small font with things, you can get a lot of data out of that. Now those are strips, and you put them through in a strip pattern this way because it busts up each word individual letters, or groups of 1 or 2 letters actually in most cases. The other one, these are the various standards. 320 square millimeter per particle, 160 square millimeter per particle, and then we get down to 400 particles is the second most common standard. That equals that each particle, if you want to call it that, is 155 millimeters square. We're now at that point where it's a shred that's cut 10 times over or more. Now, how large is that? Well, that's the length of the paper and about that wide. But that works out to being a specific number of square millimeters. The next numbers below this go really quickly down. They work out at they skip some of the sizes, go to 30 millimeter square millimeters per particle. Then we get down to 37,000 particles, or 3,700 particles. That's 16 millimeters squared, or a 4 by 4 millimeter square. That's at the point dealing with something that's around the size of a standard word. You could use 80 column mind like I do when you're typing up a standard typewritten page. That's 2 kbytes per page. That's 80 columns. If you cut this into 40 some strips, you're getting 2 letters potentially on each strip. This chops it down to the point that you have 4 millimeter by 4 millimeter squares if they're square. Most of them are in strips. The next standard down is 10 square millimeter per particle, which makes it around 12 millimeters long, and then some small number cutting it width, making it a little curlicues. There's a specific reason for that. Cutting it into, confetti, true confetti cutting, requires a lot more cuts. And then we get to 5 square millimeter particles that are 1 by 5 millimeters. That's almost hair thin. The other method, the trillions of particles, and the square millimeters is subatomic almost. Well, it's actually atomic level. Annihilation. The paper is put into a nuclear furnace. Next, cheaper method, light it on fire and grind up the powdered soot. The reason that's not done is that's ridiculously environmentally unfriendly unless you're using it to produce energy, in which case you burn all of your shreddables as fuel, or repulping. Repulping is actually the best method because it involves the least amount of energy waste and is actually cheaper. You just recycle your paper. You don't have to shred it. In fact, if you don't shred it, it has no effect, as long as someone doesn't retrieve it. You do what's called secure disposal. You simply make sure no one has a reason to grab the stuff, because it literally goes from a container you have directly to an environment where it's put into a mill and shredded or pulped entirely. It's hammer milled. Full tilt hammer mill. The reason for this is really simple. It's literally pulverized down into fibers, and then they bleach it so the data's gone, and it turns into cardboard or even recycled paper. Just recycle it. All you have to do is make sure that nobody has a reason to retrieve your recycled items. Now we're going to go for the exploits. Just like one or two people, it was actually two people at the beginning, but one person being able to disrupt thousands. What is the weakness in this? Well, number one, let's do the recycling one first. You could dump your secured documents cleaned so they don't have staples or anything on them, one page at a time so you don't have to shred them, into recycle bins all over the place so that someone would have to find all of the recycle bins and use them. Or they could just collect all the recyclables and be the recycling company. So make sure it goes to different recycling companies. That's called dithering. D-I-T-H-E-R-I-N-G, I think. The dither method for obfuscation, not encryption, is this. I'm going to bring up a really good example of a dither method, and then I'm going to apply it to our shredder here. But let's get on with the other methods that you can do that work. I mean, obviously, recycling method is actually the best if you want to do the least amount of damage. This is for anything that you don't really have to be secure. The next one is, I'll just tell you how to do it, we're going to dither shred. This is based on the dither software method, but I'm going to do the dither shredding. You buy a standard shredder. It doesn't matter what the spacing is, actually. Just get it, get a cheap one. Make sure it's durable. It has to last a long time because you're going to mod this thing so you can do this. At the bottom of the shredder, you have a mesh of a set of wheels that mesh with each other, and they have blades between discs, and they go like this. So they go through and cut it, and they cut them really cleanly. To make them grip and cut more efficiently, they're actually serrated blades that interlock like this across each other. So they do cut, but they also create dust. Now, as the strips come out like this is your front view. From the side, you see them doing this. You make them go in different directions. Every odd strip goes over here, the even number strips over here. You put them in two separate recycle boxes, and take them to two separate recycle bins. Someone would have to collect not only both bins, they would also have to collect them on the same day that you dumped them, because you use time to shred your documents. You dump the odd shreddable items once a month over here, and then wait 2 weeks and then dump the others. That's it. You just do that. And because you're doing this with time displacement, the pieces from the last shred are not mixed with the pieces from the other shred on the same timing. They're just not together. The point of shredding information isn't to make it hard to put together, it's to make it impossible to find all of the pieces. Infinity Gauntlet, put the pieces in different places. I'm sorry, but that's actually that's what I got this from. I don't feel so good. So anyway, now the dither method for software that I got this from. I don't know what its actual method name is, but here you go. You take your document, it's just whatever file it is, words only. You make a dictionary file, which contains a glossary of all the words in it. It just finds out every unique word. It then numbers each word in priority. You won't have more than 64,000 words per document most of the time. In fact, I doubt that you could ever have that happen. You then use the 2-byte code for each word, or less, and have it store it that way. The dither method is that you take every alternating byte, which means you have each word is going to be 2 bytes, the equivalent to 2 letters normally, and you send them by 2 different pathways via email, and the person takes them and then interleaves them back together. If it makes sense on the top, which is where the dictionary is that you're using, that's good. If it doesn't, you swap them. And at that point, you can reconstruct your document through 2 different email pathways. Obviously, if you shred one of the email accounts, you can't recover the other one, because not just every other letter, but the entire meaning is gone, and it's unique per document. It's not encryption, it's obfuscation, but it does work. That's where I got the idea from partially. If you lose one of the email servers, you can't get the other. So you only have to control one of the email servers completely, or just erase the email account, or just scramble the password and not try to retrieve it again. That's where I got the idea from. But this shredder method is actually cheap enough. But again, if it isn't really sensitive, just recycle it. They're not going to get it back. It's going to be a cardboard box, and UPS will take care of that. Thanks for watching. Have a good day. Good luck with that, and watch out for those 1 or 2 people disrupting your